In level 4, you'll be using your calculator to solve inequalities. And the inequalities might have some weird functions going on, so they may not all be polynomials, but we're going to be using graphs in our calculator. So in this first example, it says determine over which intervals g of x minus f of x is greater than 0. So I'm going to plug g of x, which is 3x minus 5, and f of x into this inequality. And we want to know when this is greater than 0. And all you're going to do is plug, well, first of all, always make sure you have 0 on one side. If you don't, subtract terms or whatever to get everything on one side, then plug your expression into y equals in your calculator. For many of these graphs, the standard window might be fine, which is negative 10 to 10 for the x values and negative 10 to 10 for the y values. And remember, a shortcut to get your standard window is zoom 6. And that works fine for this particular graph. If you look at the graph, the function looks something like this. And it keeps going up in this direction. And what we're trying to figure out is when is this function greater than 0? So when does it have positive y values, or when is it up above the x-axis? This particular graph is up above the y or the x-axis from its x-intercept right here, and then moving to the right. So we want to give that an interval notation. So what we need to find is what is that x-intercept right there. And remember, to find an x-intercept, you're going to do second, trace, and then you're going to choose 0. And you go to the left, you go to the right, and you find that x-intercept. And you should get the point 2.16, 0. Okay. So the interval where this graph is positive, or has positive y values when it's up above the x-axis, is going to be from, and I'm going to use a parenthesis because we don't want to actually include the point, about 2.16 to infinity. Remember, if you don't have the line underneath your inequality symbol, we always use a parenthesis. So about 2.16 to infinity. In this next example, we already have 0 on one side, so we enter the function into y equals. Remember, when you enter a fraction into y equals, you need parentheses around the top and parentheses around the bottom. So when you enter this into y equals, it should look like x minus 2 in parentheses divided by x plus 5 in parentheses. And then when you look at the graph, again, you can start with this. You might want to zoom out a little bit for this one, but your graph should look something like this. And we haven't, this is called a rational function. We haven't really studied these yet, but it has an asymptote. And you're going to have to think a little bit in some of these level 4s about what the domain of the function is. So going back up to our function, there's an x value I'm not allowed to have in the denominator. I can't have a 0 in the denominator, or the graph would be undefined. And what x value makes me have 0 in the denominator? That would be x equals negative 5. If you trace your graph, you'll find that, like, if we kind of trace it to the left, as the x values approach negative 5, the y values get lower and lower towards negative infinity. And if we trace it over here on this part, as we approach negative 5 from this direction, the graph is shooting up. So we actually have something called a vertical asymptote right here, and the graph approaches that line but never touches it. So the question is, when is this graph greater than or equal to 0? So we want to know when it's above the x-axis, and that's going to be the part over here. So it's going to stay above as we move to the left in this direction. So our answer in interval notation is going to be negative infinity to negative 5. And I'm going to use a parenthesis because the graph will never actually hit an x value of negative 5 because that would be undefined, but it gets closer and closer to negative 5. And one last example. Again, you want to get 0 on one side. So we want the absolute value of x. I'm going to subtract the square root of x. So minus the square root of x is greater than 0. We plug it into y equals, and the graph looks something like this. And we want to know when it is greater than 0. So when the graph is above the x-axis. It looks like it equals 0 at the origin, and then again over here, this is the part where it's actually greater and it goes up. But this time we don't want to know when it equals 0, we only want to know when it's greater. So I'm not going to include the places where it equals 0 in my answer. I need to find this point right here. So I find the x-intercept, and you should get the point 1, 0. And so the interval where this function is greater than or equal to 0, I'm going to use a parenthesis because at 1 it actually equals 0, and it would go to infinity after that. So I use a parenthesis around 1 so I don't include that actual point, and then we always use parentheses around infinity, and that would be the interval.